Hey guys, it's Miss Banning. We're currently in the middle of Unit 2, Coordinate Geometry. So far we've talked about patterns, linear and quadratic. We've talked about midpoint on Monday, and then distance today. The rest of this unit is kind of designated towards different equations of lines, specifically stressing parallel and perpendicular lines. If you have not done so already, before we continue, go ahead and take out that Unit 2 dictionary and take out that Unit 2 study guide. Alright, the three forms of equations that we're going to be exposed to tomorrow, two of which you're probably very familiar with. There may be one, this one right over here on the left, point slope, that's not as familiar, but we will be using it over the next couple of days, so we'll develop that comfort level with point slope. First off, addressing the bits and pieces, the different terms of each equation. In point slope, you have an x sub 1, y sub 1. That is any point that lies on the line. It doesn't have to be an intercept, simply any point that lies on that line. The m value you're very familiar with, slope. We're going to be talking a lot about that. Okay, so those are your two key pieces for point slope. Slope-intercept. Last year you probably dreamed about slope-intercept. You were working with it so much. You know that your m is slope. You know that your b is y-intercept values. Before we get to standard form, let's talk about how we can refer to slope in some different ways. We could say that slope is rate of change. You'll hear that phrase tomorrow, Thursday, and Friday, and every other day that you have a math class. Another way to talk about slope is to say coefficient. It is the coefficient or the multiplier of the x term here. Last but not least, we could say that slope is rise divided by run, or rise over run. And hopefully those are setting off some bells in your head. We're remembering more and more from Algebra I to bring with us into class tomorrow. Now, standard form looks a little bit different. Okay, some different notation there. We've got the a, b, and c. A, b, and c, your coefficients and constant, are going to be any real number. Positive, negative, fraction, decimal, integer, doesn't matter as long as it's a real number. There is a restriction, however. A and b cannot be 0 at the same time. Cannot be 0, at the same time. The reason for that being, if you had 0 times x and 0 times y, that would simplify eliminating the entire left side of your equation, resulting in 0 equals c, which may be true or may be false. Okay? Now that we know the bits and pieces, let's do some work. Let's come up with a mapping, and this may become a very valuable piece of information for you as we travel through the rest of this unit. Okay? We're going to draw some arrows connecting these boxes to each other. Some will be one directional, others will be two directional. Here we go. If you have point slope, you can convert to slope-intercept form, or you can pull a point and a slope from that equation. If you have a point and a slope, you could substitute them in to the point slope equation. So notice this is a two-directional arrow. If you have a point and a slope, you could also plot that point and use the slope to find additional points on the graph. Down at the bottom, if you had 2 points of information and that's all you had, what could you do? Well, you can find that slope value, which can then lead you other places. With 2 points, you could also go straight to the graph. Moving more towards that middle column, if you had slope-intercept, what could you do with slope-intercept? You'd know your slope and your y-intercept, which is a point. So you could slide right over there to a point and a slope. You could also go to the graph, and we'll practice with that in just a moment. From the graph, where could you go? From the graph, you can pull 2 points. From the graph, you could pull a point and a slope. And from the graph, with those pieces of information, you can actually go straight to slope-intercept form. Let's head over here to the right column. With the right column, standard form, you can convert that to slope-intercept. I consider that to be a critical skill. We're going to practice that in just a moment as well. You can also take standard form and pull your intercepts, x and y, using the cover-up method. We'll talk about that in class as well. With the intercepts, where could you go? You can go straight to the graph. Depending on the line, you can also go back as well. Okay? It depends on the scale of the graph and how it's plotted in its current screen. This is very much a resource for you for the rest of this unit. If you read a problem and you know that you have 2 points, you can come to this reference and say, all right, I'm here. I know I need to get somewhere else. How am I going to get there? So this is an excellent resource for you to carry with you throughout the rest of this unit because you're going to be exposed to a lot of types of problems. Next up, some practice. First off, we're going to take the equation. We've got 2 of them. Plot them on the graph. You have a slope and a y-intercept. Start with that y-intercept, dropping down 4, first dot. We've got a positive 2/3, positive 2 rise, go up, positive 3 run, go right. Up 2, right 3. Up 2, right 3. I ran out of room, so let's consider if I need to go backwards, reversing both directions here, so I can go 2 down and 3 left. Go ahead and connect those dots all the way to the edge of your graph and arrows at each end. The second equation, same process. Plot your y-intercept first, positive 1. The slope here, negative 1, tells us 1 down, positive 2 in the denominator, 2 to the right. From your point, 1 down, 2 right. 1 down, 2 right. And again, 1 down, 2 right. Go ahead and connect those dots, extend to the edge of your graph. So going from equation to graph, start with your y-intercept, then use the slope to travel the rise and the run to identify a second point on that line. Heading over here, let's reverse the direction. Let's start with the graph and write the equation. Well, let's pick one to be L1. We're going to pull 2 points from each line. So I'm going to identify this point right here and this point right here. And it could be any 2 points, but I'm going to choose 2 that sit on the grid lines to make counting my units really easy. All right, so what's my slope? My rise over run. I'm going to fall 1 down and go 1, 2, 3 to the right. Negative 1/3. Next, consider your B value. Negative 3. Writing your equation, putting the correct value in the correct position. Negative 1/3 x minus 3. Second line. This is going to be our L2. Again, pick 2 points. I see one here on a grid line, and I see one up here on another intersection. Let's pull our slope. Consider your rise over run. 1, 2, 3, 4 up. That's positive. And let's go 1 to the right, also positive. Slope value here, 4 over 1, and continue to simplify integer value of 4. Find your y-intercept. Where does this line cross the y-axis? Right there at negative 2. Writing your equation, y equals 4x minus 2. If you have any questions or concerns about this process, jot those down so you can ask your teacher tomorrow. Next up, the critical skill that we want you to be bringing in tomorrow, converting from standard form to slope-intercept form. Here we go. Standard form, x and y are both on the same side. Where do we want to end up? We want to end up with y equals mx plus b. So I think the first thing we're going to need to do is move that x term over to the right. Okay, so now we've got all the terms in the correct position, but the only thing that we've got left is we need that y coefficient to be 1. Divide by -2 every single term. Cancels on the left, coefficient is now 1, negative over negative is positive, so 3x and -2. Next up, in the middle, your goal is to try and beat me. Here we go. If you're done and you're saying, okay, I got some fractions, is that correct? Guess what? How does your answer compare to my answer? It is okay to have fractions for your slope and y-intercept. Last one. Again, your goal is to try and beat me. Here we go. Okay, check your answer. Did you end up with 1/2 x plus 9/2? All right, so think about everything that we talked about. We introduced and refreshed the 3 types of equations that we're going to be using. We talked about the bits and pieces, the different variables involved there. We made a mapping of if you were given a specific piece of information, what could you do with it? Where could you go? What could you find? Okay, based on what you need. Next, we practiced graphing equations and pulling the equations from a graph. So we worked both directions, slope-intercept wise. And finally, converting standard form to slope-intercept, which is critical, my goodness, critical. If we need to practice that in tutorials, I would love to practice that with you. Okay? Please bring any questions to your teachers. Have a wonderful night.